inverses. The hottest temperature ever recorded in Montana was 117 degrees Fahrenheit on July 5th, 1937. To convert this temperature to degrees Celsius, subtract 32 from the Fahrenheit temperature, and then multiply the results by 5/9. The formula for this conversion is C equals 5/9 F minus 32. The coldest temperature ever recorded in Montana was negative 57 degrees Celsius on January 20th, 1954. How do we find this temperature in Fahrenheit? So we have this equation, Celsius equals 5/9 Fahrenheit minus 32. If we know the temperature in Fahrenheit, right, so if we want to find the Celsius temperature that corresponds to 117 degrees Fahrenheit, we would just plug that in for F and we solve. 5/9, 117 minus 32 is going to be 11 minus 3 is 8. So 5/9 of 85 is 47.22. degrees Celsius. Now, if we have the temperature in Celsius and we want to solve for Fahrenheit, we can do the same thing, except put the negative 57 in for Celsius. And then we have to solve for Fahrenheit. So we would undo every step. We're going to multiply this by 9/5, which is going to be -102.6 equals F minus 32, and then add 32. Which gives us a Fahrenheit temperature of -70.6. Or we can, so that's one way we can do it. Or we can, if we want to be able to find any temperature C, we can take the function C equals 5/9 F minus 32, and we can solve this for F if we want to find any Fahrenheit given the Celsius. And so it's the same as what we did here, except instead of having a C as -57, we just have C as a variable. So we still multiply by 9/5. And so we get 9/5 C equals F minus 32, and we add 32 to both sides. So we get that Fahrenheit equals 9/5 Celsius plus 32. So this gives us an inverse function. Two relations are inverse relations if and only if one relation contains the element BA whenever the other relation contains the element AB. So for every point AB or XY in the function, the inverse has that same point with the X and the Y switched. The notation, the inverse of f of x would be f inverse, f to the little -1 power. However, f inverse may not necessarily be a function. To graph a function or relation and its inverse, you switch the x and y coordinates of all the ordered pairs of the function. And this is going to result in graphs that are symmetric to each other with respect to the line y equals x. All right, so if f of x equals the set 3, -1, 5, 2, 8, 4, and -6, 4, f inverse is going to be a set of points, and it's going to be the same 4 points, but with the x and y switched. So instead of 3, -1, it's going to be -1, 3. Instead of 5, 2, it's going to be 2, 5. Instead of 8, 4, it's going to be 4, 8. And instead of -6, 4, it's going to be 4, -6. Is f inverse a function? No, because we have one input, 4, that gives us 2 outputs, and that is not allowed. If we were to graph these, it would fail the vertical line test, because at 4, you'd have 1 point at 4, -6, and 1 point at 4, 8. Okay, graph f of x equals -1/2 absolute value of x plus 3, and its inverse. Use your transformation rules. So the parent function is the absolute value function. Transformations, it's negative out front, so reflected over the x-axis. It's going to be upside down. It's going to have a vertical compression or vertical shrink, compression, by a factor of 1/2, and then it's going to be shifted up 3. So our vertex that would usually be at 0, 0 is going to be up 3. It's going to be upside down, and the vertical compression of 1/2 means that instead of having a slope of 1, the slope is going to be 1/2. So this is the function f of x. F of x equals -1/2 absolute value of x plus 3. We don't have a way to solve this, to solve for the inverse as an equation, because we don't have an opposite of an absolute value. There's no way to undo that. But we can still graph the inverse by reflecting every point over this line y equals x, or switching the x and y. So if I label some points here, right, this is the point 0, 3. I've got a point here at -6, 0. I've got a point here at -10, -2. I've got a point here at +6, 0. I've got a point here at +10, -2. So when I switch my x and y, instead of 0, 3, I'm going to have a point at 3, 0. Instead of 6, 0, I'm going to have a point at 0, 6, and also 0, -6. And you can see how this, and then I'm going to have that point at -10, -2, at -2, -10, and -2, +10. And so this ends up looking like this. Right? And so you can see that it's symmetric over this line, y equals x. So this is f inverse of x, which we don't have an equation for, and this is the line y equals x. Find f inverse of x if f of x equals x plus 1 cubed. All right, so our steps for finding the inverse, we're going to make this y equals x plus 1 cubed, just for ease of notation. we're going to switch the x and the y, and then we're going to solve for y. So to undo that cube, we're going to take the cube root. So we get the cube root of x equals y plus 1, and then we're going to subtract 1. And so we're going to get y equals the cube root of x minus 1. And then we'll go ahead and put that back in inverse notation. Instead of y equals, it's f inverse of x equals the cube root of x minus 1. Find f of x, f inverse of x, if f of x equals x plus 1 over x minus 3. So again, make that y equals x plus 1 over x minus 3. We're going to switch the x and the y's, so that y turns into an x, and all of the x's turn into y's. Now we got to solve for y, so we're going to, that was a plus 1. We're going to multiply both sides by y minus 3. And so we need to get all of the y's over to one side and all of the not y things over to the other side, which means we're going to have to distribute this x. This is going to be xy minus 3x equals y plus 1. We're going to add 3x to both sides, and we're going to minus y from both sides. So we get all of the y terms on the left-hand side and all of the x terms on the right-hand side, or all of the not y terms. Now that we've got all of the y terms on the right-hand side, on the left-hand side, we can factor out a y and make this y equals x minus 1. Y times x minus 1 equals 3x plus 1, and divide both sides by x minus 1. So we get y equals 3x plus 1 over x minus 1. And we can then switch that back to be f inverse. F inverse of x equals 3x plus 1 over x minus 1. All functions pass the vertical line test. That is the definition of a function. If a function passes the horizontal line test, that means that its inverse is also a function. A function that passes both the horizontal and vertical line test is called one-to-one, and that means that its inverse is also a function. So this function, this parabola, this is the parabola y equals x squared. It passes the vertical line test because it is a function, but it doesn't pass the horizontal line test. So its inverse is not a function, and it is not 1-to-1. Here, this is y equals x cubed. It passes the vertical line test because it's a function, but it also passes the horizontal line test. So this is 1-to-1. And so the inverse of this is going to be a function. Okay, so consider f of x equals x plus 3 squared minus 5. Is the inverse of this going to be a function? Well, the original function would be a parabola, opens up, it's shifted 3 to the left and down 5. So the original function is going to look something like this. All right, so your original function, this is going to be this is your original function. F of x equals x plus 3 squared minus 5. and it doesn't pass the horizontal line test. So, is the inverse of f of x a function? No. Fails the horizontal line test. We can still find the inverse. So, I did already do part of part C because I went ahead and graphed this. So, I'll just make that more solid. Find f inverse. So, we can still do our steps, right? F of x equals x plus 3 squared minus 5. We'll make that y equals x plus 3 squared minus 5. Switch the x and the y. So x equals y plus 3 squared minus 5. And solve for y. So we're going to add 5 to both sides. It's going to be x plus 5 equals y plus 3 squared. We're going to square root both sides. So this is going to be y plus 3. Now the important thing when we take the square root is that this has to be both the positive and the negative square root of x plus 5. And that is what makes the inverse not be a function. And then we subtract 3. So we're going to get f inverse of x is both plus or minus the square root of x plus 5 minus 3. And if we graph that, that would be the point that's at negative 3, negative 5 should be at negative 5, negative 3. And it's going to be, this point should be at that should be, what's that, the point that's 0, 4 side. That's what's wrong there. So the point that's at negative 3, negative 5 should be at negative 5, negative 3. And we're going to have a point here. And the absolute value function, or not, sorry, the square root function would be like this. But also, we've got the plus or the minus, so that means that it also goes like this. And so this function, these two functions, are symmetric with respect to the line y equals x. And the inverse does not pass the vertical line test. The inverse is not a function. This is f inverse of x, which is plus or minus the square root of x plus 5 minus 3. So, inverse is not a function. When we graph these, they're symmetric across the line y equals x. And we can see that the inverse does not pass the vertical line test. So, two functions, f and f inverse, are inverse functions if and only if the composite f of f inverse of x, so a lot of times we've been writing this as f of f inverse of x, and f inverse of f of x equal x. So this is how we can verify that two functions are inverses. Right, so given that f of x equals 4x minus 9, 4x minus 9, switch the x and the y, and solve. We're going to add 9 to both sides. Plus 4y. We're going to divide by 4. And so we get that y equals x plus 9 over 4, which is f inverse. Now, to verify that, we can take that and plug that into the original equation. So f of f inverse of x is going to be 4 times x plus 9 over 4 minus 9. And the 4's cancel out, and this is x plus 9 minus 9, which is just x. We can also do it the other way around and plug this in here. So f inverse of f of x is going to be 4x minus 9 plus 9 over 4. And the minus 9's cancel out, and that's 4x over 4, which is also just x.